Hi everyone, this video is going to focus on double angle formulae. The last one we did was addition angles, so we know the formula for sine A plus B, and so what we're going to develop now is a formula for sine of 2A. So if we take our addition formula that we already have and replace the B with A, we get sine of A plus A on the left, which is sine of 2A. And then we replace with B with A on the right hand side. You can see we get sine A cos A and cos A sine A. They're both the same things, just in different order. So the right hand side just becomes 2 sine A cos A. There's the first double angle identity. For the cos addition formula, once again we replace the B with A and we get that. So on the right hand side we've got cos squared A minus sine squared A. If we apply that Pythagorean identity, cos squared plus sine squared is 1, we can rearrange that second equation by replacing the sine squared A with 1 minus cos squared, giving us that, or we can replace the cos squared with 1 minus sine squared, giving us that. So now we've got all these different formulas for, firstly 1 for sine A and 3 different formulas for cos of 2A. For tan, there's the formula for tan A plus B. If we replace again B with A, we get that. So on the top line we've got 2 tan A, on the bottom line we've got 1 minus tan squared A. So there's all your double angle formulas. You don't have to know how to derive them, they're on your formula sheet. It's just a matter of understanding how to use them. So there they all are. It's important to understand that these formulae link 2x with x, but if you halve the right hand side or the left hand side, you just halve the angles, nothing else. So these formulae are really handy. So something like sine of 2A is 2 sine A cos A. You could just say sine of A is 2 sine A over 2 cos A over 2. Just halve the angle on each side and you get another identity that's true. So we're going to use these to solve equations and to prove other identities. So let's do some solving equations using these. Okay, sine 2x minus cos of x equals 0. Here we've only got one choice for the double identity. We replace the sine 2x with 2 sine x cos x. There's only one that we've got there. Okay, so that equation becomes that. Now, in solving this equation, we don't want to just get rid of the cos x by dividing everything by cos x. We just want to factorize the cos x out there. So, yeah, we're kind of ignoring some solutions if we do that. So the correct method to use is to factorize cos x. Now we've got two things times together equaling 0, so either cos x is 0 or 2 sine x minus 1 is 0, in which case sine of x is equal to half. So we just solve those individually. We were going between 0 and 360, so therefore cos of x equals 0 will give us the solution of x equals 90 or 270. So we've got two solutions there. And the other one was sine of x equals a half. That means x is equal to 30, or the other solution being 150. You can, of course, do these using the unit circle. This is just showing us how to use the graph to get those. So that gives us 4 solutions to that question. Now, in doing this here, I've only got one choice for sine 2a, but I've got 3 choices for cos 2a to try and prove this thing. Looking at the right hand side, I think it makes it obvious what I want to choose for cos 2a. I want to choose the identity that has the cos squared in it, no sines at all. So that's the one I'm going to go for. Remember, when we're proving an identity, we have to show that the left hand side equals the right hand side. We can't do the same thing to both sides of the equation. That wouldn't be good at all. So start with the left hand side and then use the formulas. So sine 2 theta becomes 2 sine theta cos theta, and cos 2 theta becomes 2 cos squared theta minus 1. You can see we do some simplifying there. Divide, get rid of the signs, top and bottom. You can see the brackets, the 1's cancel out, and we get 2 cos theta times 2 cos squared theta, which is the answer. So that's just a simple example of how you can use double angle formula to firstly solve equations and to prove identities.